Hello students, welcome back. So till now we were discussing about linear permutations where we arrange objects or things in a line, but now we will discuss about when the objects are placed in a circle. Okay, so let's have a look at our next topic, that is circular permutations. So what exactly is circular permutations? So till now we were only talking about linear arrangements of objects in a straight line, but now we will talk about the permutations of objects along a closed curve, or we can say on a circle. So if I want to arrange n different objects on a circle, so I have n different objects which I want to arrange on this circle, then what I will do is basically I will fix one object. So first of all, let me say that this object is fixed, and the remaining objects will be arranged as in case of the linear arrangement. So there are n-1 remaining objects. Now this n-1 objects will be arranged as in case of linear arrangements. So there will be n-1 factorial ways. So the total number of circular permutations of n distinct objects will be given by n-1 factorial. So whenever you want to find out the total number of circular permutations, what you will do is you will fix one object, and the rest of the n-1 objects you will arrange as in case of linear arrangement. So that will be given by n-1 factorial. Now this n-1 factorial can also be written as n factorial divided by n. If I count the total number of linear arrangement of n distinct objects, that is given by n factorial, and here we are dividing this linear arrangements by n. So this n particular cases are repeated, so one particular cases is repeated n number of times. So which are this particular cases which are repeated n number of times? Let us have a look. Suppose if I consider 5 letters A, B, C, D, E, and if I try to arrange this 5 letters A, B, C, D, E onto a circle, and if I consider the clockwise arrangement of these letters, then all these 5 cases are same. If I start from here, this is A, B, C, D, E. If I start from here again, this is also A, B, C, D, E. If I start from here again, this is also A, B, C, D, E, and I am always traversing in clockwise direction. Okay, so this particular case A, B, C, D, E is repeated 5 number of times. So we will divide by 5. So the total number of circular permutations will be given by 5 factorial divided by 5. Here we are dividing by 5 because each case will be repeated 5 number of times. So the total number of circular permutations will be given by 5 factorial by 5, or we can say 5 minus 1 factorial. An important note here, anti-clockwise and clockwise arrangements, order of arrangements are considered distinct. So clockwise is not equal to anti-clockwise arrangement. We will also see what will happen if clockwise arrangement is equal to anti-clockwise arrangements. Now if there are n distinct things taken all at a time, then the total number of circular permutations will be given by n-1. And if there are r things taken out of n things, then the total number of arrangements. So first of all we will select r things out of n things, and then this r selected things can be arranged onto a circle by r-1 factorial number of ways. So the total number of circular permutations of n things taken r at a time will be given by, first of all we will select r things out of n things, and then we will arrange them onto a circle by r-1 factorial number of ways. Now what will happen if anti-clockwise arrangement is taken same as clockwise arrangement? So you consider this case. In this case, if I move clockwise, and in this case if I move anti-clockwise, I will get the same arrangement. So both of them are same if I consider anti-clockwise equal to clockwise arrangement. In this case, each particular case will be repeated twice. See, this particular case is repeated once, twice. So all the cases will be repeated twice. So I will divide n-1 factorial by 2 because all the cases are repeated twice. And what can be an example where anti-clockwise arrangement will be same as the clockwise arrangement? Example can be flowers or garland beads in a necklace, right? Now an important note, the distinction between clockwise and anti-clockwise is ignored when the number of people have to be seated around a table so as not to have the same neighbors. So we will always take clockwise equal to anti-clockwise when the problem is of this type, where the number of people have to be seated on a table so as not to have the same neighbors. Okay, let us see an example of this. Find the number of ways in which 9 people can be seated on a round table so as all shall not have the same neighbor in any two arrangements. So all should not have the same neighbors. Okay, so here we will ignore the distinction between anti-clockwise and clockwise. So we will basically take clockwise equal to anti-clockwise. So we will divide, each case will be repeated twice, so we will divide it by 2. But if my example is of this kind, find the number of ways in which 10 children can sit in a merry-go-round relative to each other. Here there is no same neighbor, there is no case like this that the neighbor should not be same, so we will not divide by 2. So the total number of circular permutations will simply be given by 10 minus 1 factorial divided by 10 minus 1 factorial, which is equal to 9 factorial. Let us consider this example. 10 students of batch have conceptual doubts in circular permutations. So there is a batch of 10 students. Mr. Vora called them in the discussion room and asked them to sit around a circular table. So Mr. Vora is the professor who called them and asked them to sit on a round table. So there are 13 chairs surrounded onto this round table. Now Mr. Vora told that his adjacent seat should not remain empty. So if this is the position of Mr. Vora, then this two seat should not remain unoccupied. So there should be some student who should sit on this seat and this seat. Find the number of ways in which students can sit around a round table. Let us consider a different example. 10 students of a batch have conceptual doubts in circular permutations. Now Mr. Vora called them in a discussion room and asked them to sit around a circular table which is surrounded by 13 chairs. Mr. Vora told that his adjacent seat should not remain empty. So if this is the position of Mr. Vora, there are 13 seats. Now this 2 seat should not remain empty. Find the number of ways in which students can sit around the round table. So there are 10 students. So out of this 10 student, I will select, first of all I will select 2 students and arrange them on this 2 seat, seat 1 and seat 2. So first of all, out of this 10 students, S1, S2, S3 up to S10, there are 10 students. Out of this 10 student, first of all I will select any 2 students and then arrange them on this 2 seats, S1 and S, this is seat 1 and this is seat 2. I will arrange them on seat 1 and seat 2 by 2 factorial number of ways. So the ways of filling the adjacent seats will be given by 10C2 into 2 factorial. Now remaining seats out of 10 students will be filled by, out of this 10 student, again I will select 8 student and arrange them on the remaining seat by 8 factorial number of ways. Thus the required number of arrangements can be given by the first case and the second case. The total case will be 10C2 into 2 factorial into 10C8 into 8 factorial. So these are the total number of cases. So in this type of problem, what you will do is, first of all you will fill up these seats which should not remain empty, and then you can fill up the remaining seats by 10C8 into 8 factorial number of ways. Now let us consider the case 2, that is circular permutations in which the objects are alike. Till now we were talking about distinct objects only. Now suppose I have a word Allahabad and I want to arrange the letters of this word Allahabad onto a circle. Now in Allahabad there are 4 A's, 2 L, 1 H, 1 B and 1 D. So the required number of ways will be given by, if I consider all as the distinct objects, if I considered all as distinct objects, then I will get 9 minus 1 factorial number of ways. Now there are 4 alike and 2 alike, so I will divide by 4 factorial and 2 factorial. So simply, first of all I will write down the total number of circular permutations and then divide by the total number of alike objects. So there are 4 alike, 4 A's are alike and 2 L's are alike, so I will just divide by 4 factorial, 2 factorial. So this was all about circular permutations, which we have seen through 2 different cases. In our next video we will cover total number of selections or combinations Stay tuned. Have a great day. Thank you.